Can you hear me?
Yes, sir.
Do you have any questions?
No, sir.
All right, I'm going to share the web page first. Can you see my web page on module 1?
Yes, sir.
All right. I have gone and added last class meeting to the web page right here. Okay. Can you see it now? Chapter 2, Swim Meeting 5.
Yes, sir.
Okay, I'm going to add this meeting also to module 1 after we're done. Now, you are supposed to work on quiz 1 and also watch the Zoom meeting if you are not clear about any concept. So Zoom meetings plus question and answers, there are a lot of questions and answers. Chapter 1, quiz and answers here. Chapter 2, quiz and answers here. So you can practically do it, watch this, and learn the material. All right? Do you have any questions about what to do in the class?
No, sir.
All right. I'm going to share my screen again with PowerPoint slides and continue from there. All right. Can you see my web page on atomic weights?
Yes, sir.
Okay. Last time when we finished, what we started was we went over concepts of matter and describe about atomic theory and everything about the size of the atom and the subatomic particles. We talked about this. Today we're going to look into the atomic mass and periodic table. Atomic mass or atomic weight is the mass of particular element in the periodic table. For example, for chlorine, in the periodic table, right here, there's a box for chlorine in the periodic table. In the periodic table, atomic symbol is given for chlorine. And that number is atomic number. This number here is 35.4527 is the atomic weight. Now the idea you need to know about how to get atomic weight is to know about isotopes of chlorine atoms. There are 2 isotopes for chlorine. Let me write it down. There are 2 atoms we call 2 isotopes, chlorine 35 and chlorine 37. 37 right here. So they have different masses. Mass of chlorine 35 is 34.97. Mass of chlorine 37 is that. Therefore, we have to calculate the average atomic weight based on those two. Okay. There are two isotopes, chlorine 35 with the mass 34.97, chlorine 37 mass with 36.97. There are two isotopes. To calculate the average atomic mass, you have to know the percentage of each one. First one is 75%, second one is 24%. This is the average calculation. Percent composition divided by 100 is abundance of chlorine 35. 24.23 divided by 100 is abundance of chlorine 37. So abundance multiplied by atomic isotopic mass, you get this number. All right. So that is the number reported in the periodic table. So atomic mass, atomic weight is calculated based on average of atomic isotopes of the element. For example, I am showing it again. This is the abundances of two isotopes, chlorine 35 and chlorine 37. So after you get the abundances from percentages, you divide percentages by 100 and you get abundances. After you get the abundances, you multiply the isotopic mass. There are two isotopes, the abundance of 35 and that isotopic mass of 35, and isotopic mass of 37 multiplied by, then you get these two added up, you get the answer. This is the atomic mass or atomic weight reported in the periodic table. So you have to understand atomic weights given in the periodic table are average atomic masses of isotopes. Most of the elements have more than one isotope. So you have to calculate average before we to report in the periodic table. Let's look at this question. Atomic weight from isotopic masses and abundances. That's what we talked about. Which of the following is a true statement of the atomic weight of an element? Its weight is based on heaviest. That's not true. Its weight is based on lightest. No. We have to consider both heavier ones and the lighter. Weight was the most abundant. No. All contribute. It is the weight average obtained from the weights and abundance of each isotope. That is the correct statement. So therefore, answer to that question is D. Do you have any questions? Okay, this is a question about sample having two isotopes. One is given here. Isotopic mass is 296.78. Relative abundance is that number divided by 100 plus. It's hard to write here. Multiplied by 5970. This divided by 100 gets that one. So answer you get is 299.33 if you do the calculation. So answer should be this one. Now it's very simple. If you are given isotopic masses and ask for the atomic weight of that element, you calculated that based on isotopic masses and their abundances. Do you have any question? Elements are classified into metals and non-metals. In the periodic table, on the left side, you find mostly metals. On the right side, you find non-metals. Metals are solid at room temperature, except the mercury, which is a liquid. They also metals are shiny, conduct electricity, and they are ductile. Ductile means you can draw them into wires, and they are malleable. You can hammer them. Metals also form alloys. Alloys are mixture of metals like brass. Brass is common alloy we use in ornaments. Brass is alloy of copper and zinc. So they are homogeneous mixtures. When you produce alloys, you melt two metals together and make a solution which is homogeneous. Therefore, alloys have different properties than individual metals creating them. In chemical reaction, they tend to give up electrons. Metals normally form cations, positively charged ions. Non-metals, on the other hand, are insulators. Except for hydrogen, they lie on the right side of the periodic table. When you look at the periodic table later on, you will find hydrogen is found hydrogen is a non-metal, is found on the metal side. This is because hydrogen forms positive ion or cation. Unlike metals, non-metals do not conduct electricity, except graphite. Graphite has some conductivity, not full conductivity. It's used in electrode of the batteries. In chemical reactions, metals tend to gain electrons, form anions, negatively charged ions. Now I am going to talk about sizes of atoms in terms of their masses, their volume, their weight, etc. Let's look at that. If you look at lead, 208, if you look at in the periodic table, atomic number for lead is 82. It has 82 protons, atomic number 82. Therefore, it has mass number minus atomic number, 126 neutrons. The mass of a lead atom is very small, 10 to the negative 23. It requires a lot of lead atoms, this is 24, to make up a 1 pound of lead 208. Diameter of an atom is normally, all the atoms are in 10 to the negative 10 meters. Virtually all of the mass of atom is concentrated in the nucleus, because nucleus contain protons and neutrons. Electrons are outside the nucleus. Diameter of a lead nucleus is very small, 10 to the negative 14. The nucleus itself has a higher density. It's very high. Atoms, as matter, don't have that much density. Nucleus is a heavily dense area. So that's the idea about atoms. Okay. I should have discussed this previously, but I forgot. Now, metals and non-metals are found in the periodic table. On the left side, you find metals. On the right side, you find non-metals. This Russian chemist, Dmitry Mendeleev, come up with the periodic table for the first time. What he did was, all the known elements at that time, they probably knew about the atomic weights, like we calculated in the previous slide. All the known elements are arranged increasing atomic weight, beginning with hydrogen. He put that in a table. He observed, when elements are arranged in this manner, certain set of properties recur periodically. The periodic table is named because it has horizontal rows. In a horizontal row, you start with highly reactive metals and end up with noble gases. Metals become non-metals, then end up with noble gases. That's recurring property for each row in the periodic table. That's why it's called periodic table. He then arranged elements with recurring set of properties in the same column. Column is a vertical row, vertical column. For example, if he arranged lithium, sodium, and potassium in the same column, because they have similar chemical properties. So he came up with the table, which is very useful in chemistry. This is the periodic table that is available today. This is not the Mendeleev table after so many revisions. This is the periodic table. When you look at periodic table, there are seven rows here. Row is a vertical, horizontal column. There are 18 7 periods, 18 columns. If you count, this is 18 vertical columns. That's one thing you notice. One other thing, some of the elements following lanthanum and actinium is put outside. This lanthanide should have been inserted after 57 atomic number, 56. But this comes after 57 is 72. 14 elements are taken out from 6th period, and this belongs to 6th period. This belongs to 7th period. I cannot erase. So these elements taken out of the main columns are to keep the similar chemical behavior for each column. Now, when you look at this, there are different colors. These are called main groups. Main groups. These are called transition elements. Transition. These are called lanthanide elements, actinide elements. So this is the main idea about the periodic table. There are rows of periods, 7 periods, 18 groups or columns, and there are main groups. One of the questions we normally ask is, what is a main group element? These tall columns, these are taller columns. Elements belong to this area are in orange. Those are main groups. Any one of these elements could be main group elements. For example, chlorine, sulfur are main group elements. If I ask for lanthanide element, gadolinium, what is a beryllium? Beryllium is a main group. What is a transition element? Rhodium, or any of them in this yellow area. Now, there's also metalloid elements. There's a ladder going down here, bordering metal elements on the left and non-metals on the right. Metals, non-metals. The elements bordering, that's boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. There are 7 of them. Okay, so they are called metalloids. They have properties in between metals and non-metals. Do you have any questions?
No, sir.
Good. Metalloids have properties in between metals and non-metals. For example, they are shiny like metals, but they don't conduct electricity like metals do. But they are shiny. 7 elements are classified as metalloids. The 7 I counted: boron, silicon, germanium, arsenic, antimony, tellurium, and tellurium. And astatine. Astatine is not written here. One of the metalloid is silicon, which is a semiconductor. Germanium also a semiconductor used in chip industry. They conduct electricity under applied voltage, but becomes a conductor at higher applied voltage. So this silicon and germanium is used for integrated circuits to create chips. Therefore, it's very important. Now I'm going to look at some of the properties of this is group 1 or 1A. This is group 2. Transition metals is to 11. Lanthanide is at the bottom of the periodic table. Lanthanide, then that's group 17. That's group 18. These are main groups. They contain groups which have certain prominent features. First group is called alkali metal. They contain sodium, hydrogen, lithium, sodium, potassium, rubidium, cesium. Second one, group 2A contains calcium, magnesium, calcium, beryllium, radium. Transition metals are the yellow area. Do you have a question?
No,
No.
sir.
I am hearing voices here. Okay, so we're going to talk about more about these properties as we go along. Like I said, these are metals, these are non-metals, these are metalloids, non-metals, metalloids. Non-metals have certain characteristics. Metals have certain characteristics. Metals have these non-metals and metalloids. So we briefly talk about it. Metalloids are semiconductors and non-metals don't conduct electricity. They are brittle. Metals have certain properties, ductility, malleability, conduct electricity. We talk about that. Let's answer a few questions. Crystal Wilkins, why you keep mic muted? Sometime I can hear you. In modern periodic table, arranges the elements in the order of. Now in the Mendeleev table, you started with atomic weights, but modern periodic table is based on atomic number of protons. They happen to be following the same trends when you use atomic number or atomic weight. But the atomic number is the best fit for creating a periodic table. Year of discovery, no. We are not arranging size of the nucleus, no. Increase in reactivity, no. Increase in number of protons. That's the correct answer. Which of the following elements is a gas at room temperature? We talked about that. Bromine is a liquid. Helium is belong to noble gas. That's a gas. That probably is the correct answer. Carbon is a solid, sodium is a solid. Therefore, correct answer is the B. Which of the following element is not a solid at room temperature? Iron is a solid. Silver is the atomic symbol for silver is Ag. Xenon and aluminum. Aluminum is a solid. Therefore, these are not answered. Xenon is a noble gas. Therefore, that's the correct answer. Correct answer is C. Elemental symbol of mercury. That's gold. That's a Latin name for gold. Symbol is Latin name for mercury. Latin name for silver. Latin name for lead. The mercury is this one. Therefore, answer is B. What is the symbol of copper? So we have the choices. This is chromium. It's not. This is cobalt. That's not. This is carbon. That's not. Copper is a Latin name. There's no U in there. Cuprium. Cuprium is a Latin name. So Cu is the correct answer. Answer is D. Now, these are the questions we asked for from the periodic table. Names of the symbols, names of elements, elemental symbols. What element is ruthenium? This is Rutherfordium, Rf. This is Rh, rhodium. This is ruthenium, Ru. Rubidium, this is Rd. So this is the correct answer. Which element symbol is sulfur? That's silicon. Sulfur is S. That's the correct answer. Scandium is Sc. Selenium is Sc and Se. So D is the correct answer. Antimony is a metalloid. Metalloid is element in between metals and non-metals. It has 51 protons. It's alloyed with lead and used in the car batteries. What is the element symbol for antimony? A is not a chemical symbol.
If they say go.
You have a question? Okay. A is argon. Astatine. Antimony is a Latin name, stilbium. That's the correct. This is chromium. So this is the correct answer. D. Group of families. Group is a vertical column. Families are horizontal rows in the periodic table. The element in a column, that's the vertical groups, are known as a group. It's not a metal. Period is horizontal rows. A series is transition metals. It's not in a column. Metalloids is not on a column. So that the column is a group. What are the horizontal rows of a periodic table? That's the period. Cycle is not correct. Families are group of elements in a group. So therefore answer is B. We're going to look at examples of certain periods in the certain columns in the periodic table. This is alkali metals. Lithium, sodium, potassium, rubidium, cesium. Alkali metals have increasing melting point and boiling points from bottom to top. Alkali metals are in group 1 or 1A. So this is the atomic weight calculated based on isotopic masses. We don't have to do each one of them. It's already done for you. So in the alkali metal group, boiling melting point increase from bottom to top. If you look at group 7A, this is 7. This is the group 1A. Group 7A is fluorine, chlorine, bromine, iodine. Fluorine is a gas. Bromine is a liquid. Iodine is a solid. So if you look at their boiling point and melting point, metals increase. Remember, metals was increasing from bottom to top. Is opposite behavior for non-metals. This is the group 7A or group 17 column number. Fluorine, chlorine, bromine, iodine, and astatine. This is the noble gases, last group in the periodic table here. Helium, neon, argon, krypton, xenon, radon. So they follow the same pattern as non-metals. So they have the same properties. Atomic melting point and boiling point increase going from top to bottom. So there's some periodic behavior in the periodic table. Which of the following elements have similar chemical properties to tellurium? You have to find the periodic table where tellurium is. Sulfur, selenium. If you look at the periodic table, this is the sulfur group, sulfur, selenium, tellurium. So oxygen, sulfur, tellurium. I had to get back quickly. I went further. Okay. Oxygen, sulfur, selenium, tellurium. Therefore, only element here is sulfur is given. It could have been oxygen or selenium. So tellurium has the same chemical properties, is in the same group. Which of the following element is classified as semi-metal? There are 7 of them. If you remember, boron is one of them. That's the correct answer. Which of the element characterized by properties of ductility, malleability, and ability to conduct heat and electricity. That's the metallic elements. Which of the following elements is a good conductor of heat and electricity? That's the metal. Carbon is not a metal, non-metal. Aluminum is a metal. Chlorine is a non-metal. Neon is a noble gas. Basically, noble gases behave like non-metals. So answer is B. Which element is most likely to be a good conductor of electricity? Argon is a gas, noble gas, non-metal. Nitrogen is a non-metal. Fluorine is a non-metal. Nickel is a metal, transition element. Oxygen is a gas. So therefore, answer is D. Now we're going to look at the electronic configuration of atoms. Atoms has a nucleus. The electrons are arranged around the atom. Nucleus is here. Now, how we show the arrangement of electrons, we haven't told you anything how to do it. So we're going to look at it. Energy, there are certain energy levels associated around the nucleus, found around the nucleus, that electrons can go into them and occupy them. Now, these levels are not continuous. Electron can, for example, is a metal nucleus is here. This is the first energy level, second energy level. That's the quantized means. According to quantum theory, electrons in atoms occupy certain energy levels. They are basically shells around the atom. Electron can found in only one of them. Here, not in between. Therefore, this idea about quantized energy levels came from quantum mechanics. We're going to look into that. How the electron, how the atom has quantized energy level outside the nucleus. Ground state electronic configuration is an electronic configuration where the electrons are lowest possible energy state. So if you have shells, first shell has 2 electrons. If the 2 electrons are distributed like this, one in each, that's the excited state. This is the ground state, lowest energy possible. We're going to look into these ideas in the coming. Right. Electrons are wave shapes. They're called orbitals. Electrons are not planetary like, they are not particles. Orbitals are electronic wave shapes. For example, electrons take up spherical shapes around the nucleus is here, like this. Electrons are found in whole area. There's only probability of finding electrons in an atomic orbital. Electron is found anywhere. So this is first shell. Second shell is this. This is first shell, 1s. The shell closest to quantized energy level shells, closest to nucleus is first shell, second shell. So as the shell number, you can have for 1s shell is like this, 2s is bigger. Three s even bigger. I'm sorry that I didn't draw it bigger. 2s, 3s, like that. These are wave shape. This shape is called dumbbell. Dumbbell. There are 3 of them. I'm showing 1s orbitals, 2s orbitals, and 2p orbitals. If you have 3p orbitals, there are 3 of them in 3 orbitals here, 1 orbital here. I'm going to tie this up in a minute. So all of them are similar energy. 3 level have 2p level has 3p orbitals. One s is s orbital. Now there are a lot of shapes. There are total of 4 shapes. This is a shape wave of an electron take up around the nucleus. These are S's, these are P's. There are 3 of them, orbitals. D is SPD, 5 of them, 5 orbitals. F orbitals, there are 7 of them. I'm going to show you how you get from the periodic table all the shapes. Okay, hang on a second. Now, these are high energy level. These are simple one. These are 1 lobe, 2 lobe, 3 lobes, 4 lobes. So they are high energy. Electron also has a spin. One of the s orbitals pick up 2 electrons with opposite spin. That's opposite spin. Now, s orbital can have 2 electrons total. P orbital can have 6 electrons. 3 times 2. F orbital, d orbital can have 10 electrons. F orbital can have 14 electrons. I'm going to show them how you get from the periodic table. Now, if you look at the periodic table in the long form of the periodic table, long means, remember these were removed from the periodic table to the bottom to keep these together, to keep the periodicity of each group. Now, this is the group 1A. That's the group 2, 3, 4, 5, 6, 7, up to 18. So this area is called S area in the periodic table. The transition metals are called D area. F areas are the lanthanides and actinides. P areas are the area to the right. So periodic table shows how the electrons are filled into an atom. If you have 4 electrons, it goes to 1s, 2 electrons, first 1s2, then 2s2, 2p6. I'm going to show them. This is the order it's being filled. Can you see here 1s is here, 2s is here, 2p is here. You follow the order in the periodic table. So I'm going to tie this up to periodic table, then you can easily get how the electrons are arranged around the nucleus of the atom. This is the periodic table you saw previously. This is the periodic table with atomic orbitals. That's the S area, that's the D area, this is the P area, that's the F area. Electrons can take up 4 shapes. Remember we talked about 4 shapes, S, P, D. Now we will give you periodic table like this on the right. How do you know which orbitals are there? This is the S area. That's the P area, D area. That's the P area. This is the F area. So we fill the electrons according to this. You start with 1s, 1s2, 2s1, 2s2, 2p1. I'm going to show you again how you get the electronic configuration. Now, these shells are same as shell numbers. There are 7 shells. Number of electrons in a shell, that's the first shell, has 2. Second shell has 18. Normally we obtain by shell number, that's the shell number is n squared. Here 2 times 1 is 2. 2n, 2 is 8. 2n, 3 is 18. So you can get that way too. Also looking at the periodic table, this shell has 8 electrons. This has 2 electrons. This has like 3. This 3D also belong to third shell. This is called 3D. So therefore 18. So you can tie this up, and 32 for the fourth shell. How do you get 32? This, and this, 14. So that altogether 32. Let's answer the question. The further a shell is from the nucleus, the larger it becomes and more electrons it can hold. That's the true statement, because shell number 1 has 2 electrons, shell number 3 has 8 electrons, 18, 32. So that's true. How many orbitals are in the P subshell? This belongs to a fourth shell. We ask in P subchat, how many orbitals there are? Do you remember this? S has 1, P has 3 orbitals, D has 5 orbitals, F has 7 orbitals. These are odd numbers, 1, 3, 5, 7. So P has 3. Therefore, answer is C. How many 3D level? 3D level is 5. Subshell and shell and subshell structure. Shells have numbers 1, 2, 3, 4, 5, 6, 7. There are only 7 shells. Which of the following will designate the principal energy of a level? Shell number gives the energy of a level. What did I say? There are shell numbers correspond to that, not any of these. That doesn't make sense. Therefore, answer is C. Which of the following sets of alphabetical letters used to designate subshell? Subshells are SPDF. Remember? This is garbage. That's the correct answer. We talked about a subshell is SPDF. How many electrons can be accommodated in fourth shell from the atom? N is equal to 4. That's the fourth period. You can go to periodic table and count them. Belong to fourth period. All the orbitals belong to fourth period. Or you can calculate 2n squared. 32. That's the correct answer. How many orbitals are in the 3D subshell? We already asked for S and P subshells. How many orbitals? We said S has 1, P has 3, D has 5, F has 7. How many electrons? Electrons are different from orbitals. Orbitals, each orbital can have 2 electrons, S orbital. P orbitals have 6 orbitals, 3 orbitals. Each 3 orbitals can, for example, S has 1 times 2, 2 electrons. P has 3 times 2 is 6 electrons. D has 5 times 2 is 10 electrons. So P subshell, how many electrons? It's a 6. Answer is D. How many electrons can be accommodated in the 3D subshell? D. D is 10. Answer is C. How many to D? It doesn't matter what this number is. That only shows is in the highest level shell. But it's still the same shell type, subshell type. Therefore, it has to be 10 again. Oh, I'm sorry. There's no 2D. In the periodic table, if you look at it, only 3D is there. There are S's are 1, 2, 3, 4, 5, 6, 7. 3D is the only one, the beginning. You have 4D, 3D. So there's no 2D subshell. Let's go back and look at it. There's only 3Ds, 4Ds, 5Ds, 6Ds here. These are Ds. There's no 2D. That's why we say there's no 2D. Finish this up. How do you get the electronic configuration of lithium? Listen carefully. This is the everything you need to know. All rest is description to get you here. Lithium is here. Can you see lithium is here? Okay. How many places before lithium? 1, 2, 3. How many electrons lithium has? Atomic number is 3. 3 electrons. So how do you feel 3 electrons to lithium is? You start with 1s1, 1s2, 2 electrons gone, 1s2, that part. And lithium is in the first right here. Therefore 2s1. The lithium is here. That's 1s, 2s, 1s2. So lithium is electronic configuration is 1s2, 2s1. From these two pictures, you can get the idea. What is the electronic configuration of beryllium? How do you get beryllium? Beryllium is here. 1s2, 2s2. Do you have any questions? How do you get boron? Is it clear to you how to get this from these pictures? Boron is right here. You start with here to here, 1s2. Here to here is 2s2. Here to is 2p1. So that's why you get this one. Carbon. Carbon is one of the, it has 6 electrons. 6 electrons. You start with 1s2, 2s2, 2p2. Do you see that? So rest of it is, all we need to know is how to get the electronic configuration. You know the atom has nucleus. Now you know electrons, 6 electrons in the carbon atom is found in the s orbitals, 1s orbital, 2s orbital, and 2p orbitals. 6 of them. S can have only 2 electrons. P can have 6 electrons. Therefore, p orbitals are not filled in the carbon atom. So let me wrap it up. For example, how do you get the titanium? Titanium is here. You have to go all the way journey up to here. That's 1s, 2s, 2p. They are all full up to here. Then you use 3S. 3S are all food. Then you go to 4S. Here, 4S. That one. Then after 4S, there are two places, 3D2. That's 3D here, right? 3D2. We also abbreviate electronic configuration with the noble gas electronic configuration. That's the argon right here. We don't write all these down. We write 4s2, 3d to 4s2. We abbreviate with the noble gas configuration. Therefore, when you get the electronic configuration, carbon is helium 2s2, 2p6. Because helium, after helium, you follow 2s2, 2p2. So I'm going to talk about this more in next class period. Do you guys have questions? Sign up the chat box, okay? Are you guys okay?
Yes.
I will see you on Thursday, all right? Okay, take care, bye-bye.
Thank you. Bye.
Thank you. Bye bye. All right. How do I get out? Okay.